Imagine a plant that can pull nutrients from meters below your soil, grow back multiple times a year, and turn itself into fertilizer, again and again. Some trials suggest it can produce up to 100 tons of biomass per acre in a single season. And once it's established, it can drastically reduce or even replace your need for external fertilizer inputs. Not once, but for years. Decades ago, scientists believed this plant could replace chemical fertilizers entirely. So here's the real question. If something this powerful exists, why isn't everyone using it? Because the answer has nothing to do with the plant. And once you see it, you can't unsee it. And here's the part most people miss. Your soil might already contain everything your plants need. You just can't access it. If there's a plant that contains more potassium than manure, decomposes faster than compost, and constantly regenerates itself, why is hardly anyone talking about it? And this is where it starts to get uncomfortable. Because the answer isn't about biology, it's about systems. The conflict between living nutrient cycles and a model built on consumption. Welcome to Rooted. We ask questions and follow them until the answers actually work in real life. Today, we're opening a chapter of agriculture that didn't fail. It just didn't fit. And by the end of this, you'll understand why this plant quietly disappeared even though it was working. And more importantly, why it might still matter for your garden today. And what you're about to see allowed some growers to completely stop buying fertilizer. Today's topic, a specific variety of comfrey, a plant that functions like a biological nutrient pump. After World War II, Europe's soils were in a quiet crisis. Fields still looked intact, but beneath the surface, something was breaking down. Years of intensive farming had drained nutrients. Fertilizer was expensive, energy was scarce, and maintaining yields became harder each season. At the same time, soil organic matter, the foundation of fertility, was steadily declining, reducing the soil's ability to hold water, nutrients, and microbial life. And this is where things start to get strange, because the obvious solution seemed simple: add more inputs, more fertilizer, more control. But this is where most people misunderstand the whole thing, because instead of scaling the problem, someone stepped back and asked a different question. Someone started researching. Lawrence D. Hills asked, what if fertility doesn't have to be bought but can be grown? And that question sounds simple, but it challenges everything, because this is the part nobody was paying attention to. Instead of looking at factories or chemicals, he looked at something most people ignored: wild plants. And one plant kept showing up, again and again. Comfrey, unrefined, messy, easy to overlook. But Hills didn't ignore it. He looked closer, and this is where everything changes. Comfrey wasn't just growing near the surface, its roots pushed deep into the ground, much deeper than most crops ever reach. In some cases, these roots can extend well over 2 meters, accessing mineral layers completely unavailable to shallow-rooted plants like lettuce or tomatoes. And this is where things get interesting, because down there, in layers untouched for years, something had been accumulating: minerals, potassium, calcium, trace elements, nutrients your crops can't reach anymore. But this plant could. It pulls them back up and stores them in its leaves, which means something most people never realize. Your soil might not be depleted. It might just be inaccessible. And this alone changes everything. Because now, fertilizing isn't about adding nutrients. It's about unlocking them. But there was a problem for Hill's research. Wild comfrey didn't stay where you planted it. It spread, aggressively. And farmers and gardeners don't want something they can't control. And this is where most ideas would have ended. But not this one. Because instead of giving up, Hills continued his research on this variety for years, selecting, testing, improving, until he created something completely different: a sterile hybrid, more specifically, a cultivated variety called Bocking 14. No seeds, no uncontrolled spreading, only controlled growth through the root cuttings, which also means every plant is genetically identical, predictable in growth, nutrient content, and behavior in the field. What used to be a wild plant became something usable, variety-specific and non-invasive. So the question becomes, does it actually work? Field trials followed, and the results weren't subtle. This plant can be cut multiple times in a single season, and every time it grows back, it produces a large amount of biomass. And when researchers looked close, they found something unexpected. The nutrient levels were unusually high, especially potassium, often higher than manure. Typical analyses show around 2 to 3% nitrogen and up to 7% potassium in fresh leaves, making it especially valuable for fruiting crops like tomatoes, peppers, and berries. And this is where it becomes even more powerful. Because potassium isn't just another nutrient. It controls fruit development, sugar levels, disease resistance, water balance. But here's what makes Comfrey Bocking 14 so powerful. Speed. Most organic matter takes weeks to break down. Comfrey doesn't. Its leaves decompose incredibly fast, sometimes within days. This rapid breakdown is due to its low lignin and high protein content, which allows soil microbes to process it almost immediately, which means this isn't storage, it's flow, which means nutrients don't stay locked away. They become available almost immediately. And that changes everything, because now you're not waiting for fertility, you're cycling it in real time. A small grower in the UK tested all this information, not because it was proven, but because nothing else was working in his garden. He planted Comfrey, used the leaves as mulch. At first, nothing dramatic happened, but then things started to shift. The soil stayed darker, moisture lasted longer, plants looked healthier, and by the second year, he stopped buying fertilizer completely. What used to be a yearly cost became a system that sustained itself. This variety Bocking 14 works on 3 levels: deep soil penetration, nutrient accumulation, closed-loop regeneration. This isn't an input from outside. It behaves like a cycle. Some systems call it a dynamic accumulator. Planted under trees, cut regularly, return to the soil. Over time, this also improves soil structure, increases microbial diversity, and reduces erosion by keeping the soil covered year-round. And over time, the dependency on fertilizers decreases. So if something works this well, why did we move away from it? Because it doesn't fit the system. Modern agriculture runs on speed, uniformity, predictability. Spreading a bag of fertilizer takes just a few minutes. Comfrey, on the other hand, takes some time. And more importantly, you can't package him. You can't standardize him. You can't sell him the same way. So it disappeared, that knowledge. Not because it failed, but because it didn't fit. And yet, it still works. Using it is simple. Cut the leaves, lay them around your plants, or turn them into liquid fertilizer. And over time, something changes, the soil improves, structure returns, life comes back. And slowly, you stop feeding the soil, and the soil starts feeding itself. Today, fertilizer prices are rising, soil fertility is declining, and we keep searching for solutions.